So next we're going to have 2 speakers in the 420 slot. One is John Hammond, and the other is Matt Rásó-Barnett.
Doing John first?
Well, yeah. Does that seem reasonable?
Sure.
Okay. All right. John Hammond. Okay, you get the Beard Man Award. I think that, yeah. John Hammond is a negative 8th level Lustre Morlock at Intel HPDD. I'm going to read that again. John Hammond is a negative 8th level Lustre. It's got it's got the little R too. Morlock at Intel HPDD. His interests include reviewing, deleting, breaking, and occasionally fixing your code. This is his 6th time speaking at LUG. Ladies and gentlemen, presenting John Hammond.
I was excited because I knew that Steve would read whatever I wrote, and so I have hijacked my half of a slot a little bit. I know in the program it said that this would be about Lemur, but I'm going to talk about where we are with HSM more generally. And then Matt will talk about the experiences at Cambridge. So we'll do a short review of HSM. I know we've been talking about it, but I'd like to say what the parts are. We'll talk about some issues with the HSM coordinator, issues with the HSM copy tools, a comparison of 2 copy tools, Lemur and LHSM tool POSIX, and I'll also mention a few other copy tools that are out there. So HSM, what is it? Well, it's a hierarchical storage management. So we can use tapes or big disks to add a second storage tier to a Lustre file system. There's a few parts to an HSM. You have the archive, which are the purple tapes there at the bottom. As part of the metadata target, you have the HSM coordinator. You may have a policy engine like Robinhood or LIPE or a bunch of shell scripts. You have the HSM agents. These are nodes where the copy tools run. They mount the Lustre file system on one hand and the tape archive on the other. So what the verbs in HSM are archive, release, restore, and a few others. So archive is taking a Lustre file and copying it to tape, say. And then it stays in the Lustre file system, but you also have a copy on tape. Release releases the blocks that are occupied in Lustre, and you just have the blocks that are on tape. And restore is the reverse of archive, so you copy from tape back to Lustre. So archive is usually happening because the policy engine is telling it to. Release is also usually driven by the policy engine. It might be driven by command line tools. And then restore, it could be triggered explicitly through CLI because you know that you're going to need these files, or implicitly when a process tries to access a released file, it will automatically trigger a restore. The process, any attempts to access the file will block until the restore completes. The data comes from the tape back to Lustre, and then the process resumes. So it's, besides the time spent waiting, it's transparent to the application. The coordinator is the brains behind HSM. It's part of the MDT. The code is inside the MDT Lustre kernel module. It maintains a log on disk of HSM actions to be performed, ones that have been performed, ones that are in progress. It manages layout locking. So this is what makes the process that wants to access a released file block. These are LDLM locks. It talks to all the copy tools, so it manages which copy tools are registered, and it sends the HSM actions, archive, restore to the copy tools, and it receives responses from the copy tools in the form of progress RPCs. Let's talk about some issues with the HSM coordinator. The first issue, and really I think the most painful issue for HSM deployments right now, is just that we're using the wrong algorithms and data structures. So the action log on disk is just accessed in a linear way. So whenever we submit a new action, it can take a long time when the log is already large. And a large log might be 1 million actions on disk. So when we add a new action, we want to archive a new file, we start out by doing on the MDT a linear scan of the log for an existing compatible action. Has the file already been, has there already been an archive request for the file? And I think this is taking minutes in some cases. So this needs to be addressed. I think there's a few ways to go about it. Probably there needs to be some in-memory hashing in front of the log, which is relatively easy. And we also need to use a better data structure than a log, something like a DT index. And I think this is a bit more work. You see some benefit from the in-memory hash, and then you probably see some more benefit after that if you, in addition, use an index instead of a log. Updating an existing action record is also based on a linear scan of the log. We have a partial fix for this in 2.10 by caching the action record locations. The HSM includes something that's called a compound ID, which is, I won't go into the rationale for it, but whenever a group of requests come in, they're all given the same compound ID, and when the coordinator sends requests to a copy tool, it will only batch 2 requests together in a single send if they have the same compound ID. So what's happening with Robinhood, say, is Robinhood sends HSM actions to the coordinator 1 file at a time. And because of this, the coordinator sends actions to the copy tool 1 file at a time. So we could be sending, 32 at a time, and then dispatching 32 at a time, and reducing RPC round trips, which would improve performance. Issue 2, there's a heavy reliance on LDLM locking to maintain the consistency of the HSM state of an object, and we don't actually use it in a very consistent way. So it's an LDLM lock is a cluster-wide global lock This could be replaced with a local mutex if chosen correctly, and that would be a huge performance win because we would avoid interactions between HSM state and things like extended attribute caching. So modifying the HSM, there's no conceptual reason that modifying the HSM state of a file should invalidate the extended attribute caches of the clients who have cached the extended attributes of the file. On the clients, we don't use extended attributes to access the HSM state of the file. We use specialized RPCs, so there's not really a concern in that direction. We still need LDLM locking to manage release and restore. That's fine, but so the benefits of local locking would be faster updates, and we would see updates not being blocked by, HSM updates not being blocked by unresponsive clients, or evictions, things like that. So here's a list of issues. I think they're from Intel, Cray, and maybe CEA, of where we are in the issues that I've just mentioned. So we see a lot of these are actually already landed into 210, and there's some that are still in progress. I think the picture is even better since this slide was written. Sorry. Copy tools. There are at least 2 copy tools. There's more than 2, but so I want to talk about these 2 at least. There's LHSM tool POSIX. This was the original copy tool written for HSM. It is a reference copy tool, meaning that it's written so that you can read the source of it, understand how to implement your own copy tool, and then, take this, modify it until it does your own, it serves your own backend type. Or you can use it off the shelf for a POSIX type archive. It is part of the Lustre source tree, so it's included in the Lustre release Git repo. It's integrated into the Lustre test framework, so every time you push a patch for review against the HPDD continuous infrastructure, your patch will be tested against LHSM tool POSIX. It's written in C. It's about, I think, 1,000 lines, 2,000 lines of C. There's another copy tool which you can find on the Intel HPDD GitHub, which is called Lemur. It's newer. It's designed with pluggability in mind and flexibility. It's written in Go. It's not integrated into the Lustre test framework or the HPDD continuous infrastructure, and it actually does not support archives created by LHSM tool POSIX. And the reverse is also true. LHSM tool POSIX doesn't support the archives created by Lemur at this time. So you have to really, if you're going to deploy, you need to choose one, and you won't be able to switch to the other at this time. I think this should have been before the other slide, but it's what is a copy tool? Again, a copy tool goes between a Lustre file system and an archive. It receives actions from the CDT. It moves data between, it copies data between the Lustre file system and the archive. And you can write your own. So using the LHSM tool POSIX as a reference implementation, You can write your own POSIX, you can write your own copy tool. Robinhood v3 includes a copy tool, or the shell of a copy tool, called LHSM tool command. And Stanford has used this to create a copy tool that uses Google Drive. So if you go to the, I'm sorry I don't have links in the deck, but if you go to the Stanford-RC GitHub, then you can see how to connect the two, and they have a very nice write-up. So what are some issues that we need to address with copy tools? Well, the reference copy tool uses the file FID as the primary ID in the archive. This was sort of the best that could be done at the time of implementation. There are some negative consequences to this. It makes disaster recovery from, say, Robinhood and the archive hard, because you can't arbitrarily assign the FID when you're repopulating the Lustre file system. It makes import, HSM import, require a rename in the archive, which may be very slow. It's incompatible with MTT file migration. This is addressed in Lemur by storing HSM archive ID, well, so an identifier for the file in the HSM archive in a file extended attribute. That could be done in LHSM tool POSIX as well, but it has not been done. Briefly, another issue is the use of KUC. This is an inflexible message format. It doesn't have the extensibility of the Lustre RPC channel. It's a bit complicated, and I think it doesn't have very good error recovery semantics. This issue affects every copy tool that exists at this point. Flow control, I think Henri mentioned as being a problem more generally in HSM. It's definitely a problem for copy tools. LHSM tool POSIX will just start threads, start a new thread for each request that it gets, and just run away if you let it. So in summary, we have actually many stability improvements from 2.9, stability and scalability improvements from 2.9 to 2.10. We have more in the works for a 2.10x. We have a lot to think about in terms of how to get better performance in terms of the coordinator. And Lemur is available for community evaluation, and we welcome your input on it. So I think I'll give it to Matt, and then maybe take questions after.
Hi there, my name is Matt Rásó-Barnett. I'm from the University of Cambridge, and we've actually been trying out the Lemur copy tool for about the past 6 months or so. So I'm going to give just a short discussion of how we are using HSM at Cambridge, and just a little bit of our feedback on that and HSM and Lemur. So I work for the Research Computing Services. I'm a sysadmin there. At Cambridge, our division sort of started out originally as a HPC-focused unit that has moved around the university over the past 10 years or so. But recently, we've moved into the main university IT department as a larger or sort of broader service for the whole university, and we're starting to sort of expand out and do wider research data-orientated things for all the departments within the university. We currently have about 700 active users from across the university. Cambridge is quite unique, certainly in the UK, in being very distributed. There's a lot of independent departments and colleges, and in Cambridge, the traditions are very academic focused. All the money and decision-making power is with the academics. So it's our model is actually very much to sell services to the academics. So we constantly are actually having to justify ourselves over why we can do something better than they can, which has actually kind of influenced how we operate. Our current infrastructure, so we have 2 HPC-focused systems that are currently still in use. There's like 2 clusters, a Sandy Bridge cluster of about 600 nodes and a GPU cluster, both of which are sort of about to be renewed kind of by October this year. And there's about 5 petabytes of Scratch various Lustre systems attached to that, still currently on version 2.1 that we're looking to migrate off of by this October date. We've also recently been purchased 2 sort of large tape archives, which have been part of our HSM rollout, amongst other things within our division. And yeah, we've recently got some national funding to deliver some new services and upgrades to our HPC systems. So there's going to be a new GPU, a new CPU Skylake cluster, and KNL system with a mixture of Omnipath and IB. And as part of that, we have a new deployment of Lustre that we're putting in place. And we've also been experimenting a little bit with some other systems, one of which is OpenStack, which we sometimes leverage for our own use cases, but we actually have sort of an interesting deployment of a virtualized HPC system for a brain imaging unit within Cambridge, who have their own Lustre system that is mounted within that, and it works very well. So as part of our new offering and as part of our broadening of approach across the university, we've been looking at how we do storage for the wider academic community within Cambridge, and not solely for the HPC community, which has traditionally just been the typical Scratch file system. There's a lot of demand that we are getting from academics and institutes who want something beyond Scratch. They currently use our Scratch in a way that they expect it to be performant and all of the good things that Lustre provides, but they want the resiliency as well. They don't expect it to operate as a Scratch. So we're looking in our next iteration to try and tackle some of these things and offer different tiers of storage, 2 of which I'm going to talk about that are involving Lustre and HSM in some way. We have another tier that utilizes sort of ZFS for a more resilient backup-based storage area. But the first one of which is we have like a research data store that we envisaged effectively as Lustre Scratch area, but with an additional, using HSM to provide an additional layer of disaster recovery, I suppose is the best way to call it. So we have a Lustre file system that researchers will buy space on, and that we have a Robinhood backed policy on it that is over time archiving these researchers' data periodically to our HSM backend, which is a tape file system that I'll talk a little bit more about in a moment. So this is, we kind of have some SSH and sort of rsync gateways that are available sort of from everywhere for researchers across the university to access, and that they can effectively dump data into, and that we manage with Robinhood. But there's we are trying to optimize the usage of HSM and our backend such that in the unfortunate case that we ever did lose an OST, that we could recover from that. And the goal here is really that we need it to be low cost as possible, and that we can recover it in some length of time. It will obviously be slower than our sort of resilient ZFS file system, but it's not completely gone forever. And the idea here, having these sort of two options for them to buy, is that we found with our researchers is that we need it to be as low cost as possible. So, because for some people, if we don't hit the right sort of price point, they will go out and just buy NAS boxes for themselves and do it in their department. So we're trying to kind of cover a lot of bases. So this is one area of that. And the other sort of product that we've been trying to roll out is more of a cold storage area. So again, we're basing this on Lustre and HSM, but here we kind of aggressively will release the data from Lustre. So Lustre is more of just the cache that data is originally put into, and it provides the namespace, and we have Robinhood and the quotering and accounting to control the users and what they're putting in there, but the data gets moved off onto the HSM backend quickly. So this is just a rough layout of how these two systems are put together. So we're using Intel's Enterprise Edition for Lustre. We're using the new Robinhood version 3, and we're using Intel's Lemur copy tool for the copy agents. We actually run our copy agents as sort of stateless virtual machines in OpenStack, and it was actually one of the reasons we quite liked Lemur for this, because as I'll talk about in a moment, but Lemur has some sort of nice quality of life things for managing as a stateless agent. So we like that. And then our HSM backend is some tape libraries that we use a product called QStar Archive Manager that sits in front of it. And that works. It handles all the interfacing with the tape library, and it also has its own disk cache that together it presents a Fuse POSIX file system that we then NFS export to the copy agents. So that's why we're using the POSIX backend or the POSIX data mover for Lemur onto these NFS exports. And I mean, I've included a slide of the hardware setup that we use, but I won't talk too much about that. So our experiences with Lemur have been really positive. We initially started out testing it with the LHSM tool POSIX, and I mean, at the same time we were kind of taking our first steps with HSM. So we kind of ran into a number of issues, a few stability things, not necessarily to do with LHSM tool POSIX, some to do with the coordinator, some kind of fairly famous, I think, or infamous kind of issues, such as playing around dynamically with the size of the max requests parameter in HSM that I think a number of other people or have told me about the not to do that I know now. But yeah, we initially were reached out to by Intel about that they were working on Lemur, and we switched over to that in about October last year, and it's included a number of things that have made our lives a bit easier. It's multi-threaded, and we've been able to kind of tune it to maximize our throughput to our backend, such that we can saturate the bandwidth of our HSM backend. So we've been very happy with its performance, and it's felt a bit more stable in terms of kind of stopping, restarting. Sometimes if you have a copy agent that has fallen over, kind of restarting it and that being noted by the coordinator and restarting again. Lots of little things like that we've sort of felt that Lemur works very well with. And yes, it's kind of felt to us that it can handle kind of a higher job throughput than the LHSM tool POSIX. So we've been able to kind of bump up our value for the max request setting in the coordinator, and it's been been able to churn through jobs very quickly for us. And lastly, it has it's sort of managed as a single systemd unit. It manages the Lustre mount points for you as well, which is just a nice little thing. It kind of helps again with our aim that we wanted our copy agents to be completely sort of stateless and easy to quickly spin up and down in OpenStack. So yeah, our experiences with Lemur have been very positive. It has required some changes to Lemur in order to better integrate with Robinhood over the months that we've been using it. It does now, since version 0.5, it now has compatibility with Robinhood version 3. So the HSM UUID that John was just talking about, it does get stored in Robinhood's database now. So you can archive and restore files perfectly as you would with any other copy tool. There's a few remaining things that I think we would like to work with the Robinhood developers and Intel maybe over the next few months if we can finish off to get Lemur completely integrated with Robinhood, such as for particularly with removal, HSM remove jobs, and the Robinhood's kind of delayed removal or the recovery, the undelete functionality, both of which don't currently quite work with Lemur. So there's a little bit of work to do there. But yeah, we've kind of developed some simplistic scripts that work around this, so it hasn't been a major issue for us at the moment. And there's lastly some really interesting features that are kind of being implemented in Lemur sort of as an experiment at the moment that we're not using in production, but we're very interested in, such as it can do sort of in-flight compression of the data before it's sent to the backend, and also doing a checksum of the data, which could, with some work, it could be integrated to then store that checksum in Robinhood, which would be a very kind of efficient way of doing that because it's already, got the file read, and it would be the perfect time to do that checksum and store that in a database. So yeah, we're really positive and looking forward to see how this develops and if we can help. So yeah, we're still in the early days of using HSM for these two file systems. We've only got sort of a few hundred terabytes or so in across the file systems. We've been trying it out on a few other experimental sort of file systems that we have, some of which have a lot more files in them, and we've found that some of the issues that John was talking about with the scalability of the coordinator dealing with large archives has been sort of one of the issues that we've encountered there. So I think that's one of the main issues that we run into right now. We've kind of had to keep an eye a lot on the coordinator queue size and ensure that we're not pushing in too many jobs at a time, particularly with the kind of policies that we're running on these file systems. We can, if a user uploads a large amount of files, then we need to kind of stagger that, otherwise the queue can grow too large and slow everything down. So I've kind of noted some of these tickets in here, but I mean, from actually listening to a lot of the talks from both today and yesterday, I think a lot of these have already been picked up by the developers and other sites. So I won't go into them too much here. I think lastly, this issue of kind of playing around with the value of max requests is something that we're quite interested in. So I think it's been mentioned before that, if you kind of reduce this value while it's running, it can cause the the number of HSM active requests to balloon out of control. But also with the way that we are using these stateless kind of copy agents, we originally envisaged the idea that we could kind of spin these up and down on demand. So one of our sort of wish list items would be whether this could be more of a dynamic tunable in future, such that maybe the HSM agents could actually inform the coordinator more of how much work that they would be able to accept, so that you could just kind of turn on a number of copy tools if you saw the backlog of queue actions growing large, and allow that to be more dynamic. And also, I suppose another issue that was mentioned in the previous talk about having kind of a more of like a quality of service on the queue. So we've also run into this issue where if you have a large amount of archives or restores in the queue, that kind of blocking other operations that you might deem to be more high priority. So I'm aware of the patch that's there for that, and I think we would like to try that out shortly. But also for our kind of cold store type service where we actually envisage the users to be the ones who would be submitting most of the restores and not have it driven by a policy engine, it kind of occurs to me that having the coordinator queue something that we're able to manipulate a bit more and have maybe even more complex quality of service there, such that one user cannot perhaps block the HSM action active requests with all of their restores and stopping anyone else, any other users from having their own restores perhaps serviced would be, perhaps an extension of that, that maybe would be an interesting idea to see. And yeah, that's everything. Thank you.
We're going to invite John back up and take a question or so.
Any questions?
Maybe a stupid question. Can the coordinator be separated out of MDT? I mean, some kind of remote setup?
Well, it could be. I don't think this is a good way to get at the performance gains right now. I mean, yes, there would have to be some part of it left behind, some hooks to manage layout locking. It's something that's been talked about and considered. It's not my favorite idea right now.
I have just one simple question. Has anyone working on a HPSSS interface to Lemur?
I don't know of it.
Okay, thank you.
Did you mean HPSS? So for Lemur, I don't know, but there is an HPSS copy tool available. We developed one, so it's open source. If you have an HPSS license, of course.